Good morning, everybody. Thank you for joining us today. My name is Pires da Silva. I work for Black River Engineering as a pavement engineer. Our scope of work for this project is to conduct a comprehensive assessment of the proposed Riverview Highway intersections and bypass construction project. We also produce the pavement design for both the new bypass and the intersections. The new and soon-to-be upgraded infrastructure is crucial for enhancing connectivity and ensuring improved access within the Riverview area. As you already know, we have prepared an engineering report that specifically addresses the essential pavement components of the construction, including the subgrade layer, subbase, base course, and wearing course required for the implementation of the 8-kilometer bypass as well as the 2 intersections. Now, this presentation is a discussion of what our findings are, the potential challenges, and recommendations to mitigate or eliminate those challenges. So we have some existing data and documentation that we analyzed and assessed and reported in our engineering report. One of those is in relation to the geotechnical data and documentation. We understand that a field investigation has been completed. Our review finds that it is characterized by substandard soil conditions with a CBR of 3%. And I have to clarify that this is for the northern section of the bypass. The area is primarily composed of silty clays and plastic clays, which will require removal of unsuitable materials and replacement with engineered fill. However, it is in our opinion that further investigation is required to determine depth of unsuitable materials and understand existing in situ materials properties, Atterberg limits, and also MMDD. On the other hand, the southern section presents improved soil conditions. Can I just clarify quickly that this is the northern section, the line in orange, and the line in green is actually the southern section. Let me repeat that one more time. So on the other hand, the southern section presents improved soil conditions with a CBR of 10%, allowing for a more straightforward construction process, although adherence to established engineering specifications remains essential, obviously. In saying that, it is a standard practice in WA to prepare the subgrade by scarifying down to 150 millimeters depth and recompact it to 95% MMDD to ensure stability. So, the other information that we've got, or the preliminary design for the pavement, is single sprayed seal design for both the northern and southern section. However, it is in our opinion that this single sprayed seal design may not be sufficient to support heavy vehicles route of the new bypass. Preliminary investigation works have very limited information regarding the in situ soil testing and results. There have been no detailed design or drawings provided to BIE to support our assessment and analysis of the existing data and documentation. In addition, there is also no feature and topographical survey data of the site. In terms of intersections, it will involve widening of existing sealed road to enable the construction of 3 auxiliary lanes for a left-in turn onto bypass road, which is eastbound, left-out turn onto River Highway, southbound, and right-out turn onto River Highway, northbound. This design layout has been identified as the safest layout for River Highway for the new intersection, as it provides dedicated auxiliary lanes for turning vehicles, which will improve safety of other road users. This will increase construction costs. However, there are ways to reduce costs. Excuse me. And the reason I say that is because there is an opportunity to reuse the pavement materials, the existing pavement materials or pavement structure of the existing road. So instead of reconstructing the whole area, parts of the existing road, we are going to save the existing pavement structure and remove the existing seal and replace with asphalt. But under one condition, that when we conduct our additional investigation, it will confirm that existing pavement structure is actually sufficient and has the bearing capacity to support the traffic. So on this slide, just wanted to quickly recap again of what I've just mentioned. So this is the Riverview Township, and that's the River Highway. That's the Black River flowing through. The orange one is actually the 3 kilometers northern section of the bypass, and the green one is obviously the 5 kilometer section of the bypass. So we've just talked about geotechnical. There are also matters in regard to pavement design. I'm sorry, actually, I'm going to talk about environmental matters now. What we know so far for the northern section, there is protected wildlife and remnants of significant vegetation. We don't exactly know where they are located. Their locations haven't been located or identified on site, and that includes remnants of significant vegetation. For the southern section, landowners have been critical of the project and have objected to the acquisition of their land for its construction. There are also crops that are sensitive to dust and contamination. Now, with regards to pavement design, it has been proposed that the pavement or the wearing course for the pavement design should comprise of single spray seal design for both northern and southern sections. BRE thinks that this might not be sufficient to support heavy vehicles route of the new bypass. The other information that we've got is that preliminary investigation works have very limited information regarding the in-situ soil testing and results. There have been no detailed design or drawings provided to BRE, and there has been no feature and topographical survey data provided to BRE to support our analysis and review of the existing data and documentation. In terms of intersections, it will involve widening of existing sealed road to enable the construction of 3 auxiliary lanes for a left-in turn onto Bypass Road, which is eastbound, left out turn onto River Highway, which is southbound, and right out turn onto River Highway, northbound. Now, this design layout is a little bit different to what has been included or what has been prepared to date, because it has been identified that the revised layout has the safest layout for River Highway for the new intersection, as it provides dedicated auxiliary lanes for turning vehicles, which will improve safety of other road users. These will increase construction costs. However, there are ways to reduce cost. Now, I haven't included the screenshot of that new or revised design layout that we proposed, but it should be available in the report. And if you still can't find it, just let us know and we'll send a copy to everyone. So we have identified several issues in terms of existing data and documentation. We talked about geotechnical investigation, which is one. The second one, we talked about the environmental issues. And the third one, we spoke about the pavement design. Let's start with geotechnical. What are the recommendations? Number one, undertake additional geotechnical investigations to ascertain the specific depth and properties of unsuitable materials present. Because all that we've got at the moment is the CBR value, preliminary design of the base course and sub-base to be determined by BRE. However, the City of Karratha standards and specifications for roadworks design and construction requires removal of unsuitable materials to a depth of 400 millimeters minimum, or as per the advice provided by the geotechnical engineers. We won't be able to identify what the depth is going to be without really knowing what is underneath that layer. So the best thing to do is to undertake additional geotechnical investigation to locate the total depth of that clay material, that unsuitable material, and whether we should replace only the 400 millimeters or 600 millimeters or up to 2 meters as per Austroad's recommendations. But that's all going to be based on the results of the additional geotechnical investigation, which obviously includes testing, sampling. But until then, we're not going to be sure enough. We need to confirm with the results of the testing. In terms of environmental, our recommendations include, but not limited to, 1. Undertake environmental flora and fauna study and liaison with the Department of Water and Environmental Regulation, or DWER, for the review and approval of the Clearing Impact Assessment, or CIA, and the Vegetation Management Plan. The environmental flora and fauna study and assessment to identify significant vegetation remnants and protected fauna. Third, liaison with the Department of the Environment and Energy, or DOEE, and the Environmental Protection Authority, or EPA, to facilitate the specified environmental outcomes, including performance indicators, periodic milestones, proposed monitoring and adaptive management strategies necessary, as well as record keeping and reporting processes. Additionally, the document will outline the environmental management actions necessary to effectively manage, monitor, and mitigate both the direct and potential indirect impacts of the proposed construction on protected fauna or wildlife. The other point that we've also included in this presentation, and again to reiterate what has just been said before, there is an opportunity for savings by reusing existing pavement on northern intersection to support the traffic. As part of the recommendations, the detailed design and documentation will also need to be produced to prevent any delays. And lastly, ensure strict adherence to all construction specifications and maintain consistent communication with all stakeholders involved during the construction process. Thank you very much, and let us know if you have any questions. Thanks for your time.